Let us continue module 3. Welcome to the channel. So this is a continuation in the series where we're looking at module 3 of the Generative AI certification program from Google. So previously in module 3, we were discussing about resources when it comes to navigating the landscape of generative AI. We're talking about resources, and I mentioned about the 5 M's of management or the 7 M's of management. So for management, as a manager over the years, we normally talk about man, material, machine, money, method, management, moral values. And if we stream that down to 5 M's of management, we want to look at either man or men, money, materials, machines, method. Now, in generative AI, to deliver your AI project, you need to consider and think about what will you need to deploy that particular project? Who will you need to deploy that particular project? What processes? What's going to be the scope? How much time are you going to need? If you want to deploy a generative AI solution, people, you need to consider people. What kind of expertise do they have? So Google have no code, low code, or core API-driven systems to help you start and deploy your application. When it comes to money, so what budget do you have? Do you want to start an AI project at a very small scale, at a large scale? How much time do you have? So that would tell how you're going to work and deploy your project. Now let's look at platform. Now, when Google says platform, so what's the foundation for building and scaling your AI initiative? So Google have what is called the Vertex AI. So it's a unified machine learning platform that is intended to help you streamline the entire machine learning workflow. Now, when you say machine learning workflow, you're talking about your data, you're talking about your algorithm, you're talking about training the data set, now using that to now deploy your solution. Now, including infrastructure. And when we say infrastructure here, we mean Google services that drives, including your hardware, your system processor, your RAM. Just think about a typical PC that you have in the cloud. So this includes your servers, your graphic processing units, your transformer systems, along with the essential software needed to train, store, and what? Run AI models. So you need a lot of computing resources. So that's what you call infrastructure. In the cloud, when we say infrastructure, we just mean what are those hardwares, what are those components of a PC that you need in the cloud to be able to run your stuff. Ordinarily, in your office at home, you need a system. It can be a Core i5, Core i7, and whatever kind of machine that you have is going to have some kind of processor, it's going to have some kind of RAM, it's going to have some kind of graphics display. All of those things in the cloud, that's what we also call infrastructure. Though we still use those words in our physical servers that we have around us. In the cloud, we also refer to that as machine learning. So Vertex AI provides those infrastructure, the tools and the applications and software that you need, and also the pre-trained model. Anytime you see pre-trained model, it means you are not going to be involved in trying to collect data, see if there's patterns and relationship between that data, and that's using that data to do forecasts. So you already have models already pre-trained, like the models that you use you have in Gemini, Chat, GTP, GPT, Cloud, Grok, all of these tools. Those models are already pre-trained. They are meant to be able to deploy something. So if you are coming in now to now do a solution, let's say you want to create a chatbot, what that chatbot does is that if people or students, for instance, ask questions about some certification programs, they can reply them. So that model you are using now, you don't need to go and start harvesting data to put it in an archive. Then you train the model to be able to answer questions from prompts. You already have all of those things done for you. That's why if you want to build an AI solution, you can piggyback on already trained models. And you can look out to Microsoft, you can look out to Google, you can look out to OpenAI, you can look out to Meta, that is Facebook, guys. You can look out to what's his name again? Alibaba, because you also have Ali Cloud. I think, yes, that's what it's called, Ali Cloud. Yes. So that's what is powering most of uh the Asian Alibaba, AliExpress, DHgate, and all of that. So it's part of the Alibaba group, uh, owned by the Jack Ma guy. Now you have AWS, Amazon. So Amazon, the largest e-commerce store, is powered by AWS, Amazon Web Services. And one of the reasons why some persons need to also understand, if you don't know, you can know this now. One of the reasons why AWS is the largest uh, cloud service provider is that they built AWS services. You can look up to the history. They built AWS out of the need to serve Amazon, right? If you just say, okay, largest e-commerce store worldwide, so it's going to be Amazon. So that the number one, they have the most transactions, they have the most sales, they have the everything put together. Both the Amazon, Japan, UK, Germany, Canada, all their different areas. They are the largest. Now, imagine you have an e-commerce site, so it's going to be difficult for somebody to be able to host you. And if somebody cannot host you, host your data, your application, your software, your images, all of that, what it means is that you need to create your own. And that's what led to the AWS services. Then once they created something that was more than sufficient for themselves, they now started renting those servers, now started email services, web services, data storage, and then compute service, EC2, and all of that. On this channel, I hope to bring certifications in AWS as time permits me. I've taken the Cloud Practitioner, the Azure Sheet Level certifications. I hope to also, in the future, take the Security Specialty certification from AWS. So that validates your competence when it comes to protecting data that you have in the cloud in an AWS infrastructure. Now, I was talking about pre-trained models. So when you use models from any of these big companies, you're actually using a pre-trained model. You don't need to create everything yourself. So you can use that to build, to deploy, and to manage your AI solutions. And like I said, when you say infrastructure, that's the foundation upon which everything is laid upon. So it provides all your core computing services, which is RAM, processor, hard drive, and all the things that helps to drive it, along with essential software in there to train, store, and run your AI models. Now, AI on the edge. Now, anytime you hear the word AI on the edge, so this is what is called edge computing, right? So edge computing, normally you are going to, in a conventional cloud computing system, you have, okay, let me say in a conventional data centers. So you have your PCs or you have your servers, you have your network. It's within your enterprise, it's within the company where you are. So you store your data there, you have your network and all of that. Now, when you say cloud computing, you're typically saying, I no longer want to have these things physically present with me. I want to have it somewhere, anywhere in the world that I can have access to it 24/7 and any of my customers from anywhere. I don't need to maintain the processors, the hard disks, the SSD drive, the SSD, the processor, the servers, networking, uptime, downtime. I don't need to stress about all of those things. I just pay on demand. So if I need 10 terabytes for like 10 seconds or 10 terabytes for 1 hour to host something for people to view it, download it, and I shut it down, I can do that. So that's different between cloud computing and your regular conventional computing. Now, when you now talk about edge computing, so this is what you call distributed computing. When instead of keeping it within your physical enterprise or keeping it in the cloud, you now keep it closer to where you're going to be doing the service. Not physically, not completed completely remotely, right? But close to the point where it's going to be processed. So it's like a hybrid, like a quasi uh, cloud computing service. But the most important thing you need to know about cloud computing is that it is closer to the customer. And the core goal is to reduce latency. So that's the word there, to reduce latency. And when you say latency, you're talking about the time between which data can move from point A to point B. So instead of having it completely in the cloud, you don't want to do that. Instead of having it physically with you, you want to have it closer to the point where you're processing. Imagine if football match is going to be played, people are going to be viewing from different places. That's one of the reasons why a lot of cloud service providers a lot of cloud service providers have edge centers, right? Edge locations. So these edge locations are endpoints. They are closer to the users so that they can reduce latency. They can increase the speed between which users can communicate with the data centers or communicate with the, what's it called? Communicate with the cloud server. So it's like an intermediary. So you have the customers here, you have your remote server. So you just have something, some data centers kind of in between, systems in between to like reduce the time between which data is going to travel from here to this particular point. So you could study more about it. So here, when you say AI on the edge, so we're trying to say, can we run AI solutions on infrastructures closer to where the action is happening? So if you're streaming in within a seashore, so the time it will take data to be transferred from that seashore to wherever data center is, let's say in the US, and this is happening somewhere in the Caribbean or somewhere in Asia or somewhere within Africa. So the time is going to be longer, but if you have like a mini data center on edge system that's closer to that, what's it called, where that streaming service or record service is happening, it makes it faster. Google also provides the light runtime to help developers deploy AI machine on edge devices. Now, Gemini Nano, so this is just like a minified version, most efficient, compact AI model designed to run on devices. So it's smaller compared to the running Gemini at large scale. And if you wonder what an edge device looks like, I'm conversant with the ones from AWS edge devices from AWS, just small machines that have high compute, what's it called? High compute capacity, right? So this is what an edge machine looks like. It's just like a mini computer. So you could do IoT, you could do Internet of Things, you could do computing, you could do whatever. So it just serves as a medium between, let me see if I can see a small image to show you what it looks like. But I think this is going to do the job. Awesome. So this is like your operational facility where you're doing all of your hardware. Okay, this looks like a service deployed either in healthcare, in mining, in telecoms, in electricity, this mining, maybe these banks, in transport, in logistics. This is like oil and gas. This is like wind turbine, all of those kind of stuff. Now you're processing a lot of data. So instead of you trying to deploy all of this straight to AWS, you could have something closer. This is Edge Gateway. Have something closer to where it's happening so that you can easily transfer data between your systems and AWS Cloud or GCP or Azure. Now, and it also helps for what's called queuing. You could queue services, especially when you have torrents and torrents and torrents of data moving. This course is actually beyond the scope of some of these, will I say, advanced stuffs. But if you intend to take the Google associate certifications or the professional certifications, you get far more clarity about all of this. But just understand that Gemini Nano It's just a minified version of your regular Gemini program that can run on those edge devices. And let's look at the Gen AI landscape. Understand that it consists of the Gen AI powered applications. It consists of the agent, consists of the platform, model, and what? Infrastructure. So agents is an application that tries to achieve goal by observing the world and acting upon it using the tools at its disposal. So an agent is going to help you do quite a lot of things. So it can be to reason, it can be to act, it can be to plan, it can be to interpret. These are components of AI. And don't forget, anytime we say AI, we're just trying to say, can we do things without going back and relying on human intelligence? Can we do things and make it faster? Can we do things and automate it? So an agent is going to help you do that. So you have the reasoning loop. So an iterative process where the agent observes, interprets, reasons, acts, often using prompt engineering. So the way you can interact with an agent is to prompt engineer. So I'm going to try to do a separate series or a long video that is going to address prompt engineering. So don't forget to subscribe to the channel. Aside taking the generative AI certification, one important skill set you want to have is to how to prompt engineer, is to how to talk to AI agents so that you can get the best response. So because once you do that properly, it will help them to be able to interpret, reason, and of course, act and give you replies. So you have tools and also you have models, of course, the brain of the system. Now, Vertex AI gives you options on how to handle AI models. So you have the model garden. So this will help you pick from existing Google or third party or open source model. Then, of course, you have the model builder. So you could fully go custom or you could create your own models at scale using any ML framework or use AutoML. So AutoML, it's for persons. If you see an exam question that is asking you about what should you go for if you have minimal technical knowledge and effort, it should be a model builder. Rather, it should be AutoML. So this is not a no code, right? It's a low code. Whereas this is a code-based, because this one, you'll have to piggyback on the Vertex AI system. And you do that through the API. An API is just like an interface between your application and the source. If it's Vertex AI, for instance, you're saying you want to create your own software, but you want to piggyback on Google's own, what's it called? You want to piggyback on Google's own system. Now, let me give you an instance. So let's just go to Gemini AI and let's do something. Let's say we want to create a very small, let's say I want to create a minified, let's say JavaScript wallet system to for let's say staff purchases on a mini portal, right? And I want to piggyback on Vertex AI to help track staff expenses and using some other sets of rules by admin to allow expense from company central wallet or reject expense. So this is a very simplified way to say you want to build a system, but you want to use an existing model to now deploy your system so that it can be AI driven. Now, this is not a no-code system. This is a code-based system. So you need programming skill sets to be able to deploy this. For instance, using Tailwind CSS, Now, it's still writing the system. Awesome. So it has so much done. So I will just read through and explain what the code system is, what it has built out. So here we have, okay, I'll help you build a minified JavaScript wallet system for staff purchases. The system will allow staff to make simulated purchases, track their balances, then view transaction history. For the piggyback on Vertex AI and admin roles, I will include a placeholder function to simulate approval process. Now, the approval process is not going to be it's not going to be human driven. That's why we call it artificial intelligence. Now, I will include a placeholder function that's going to simulate the approval process. As true AI integration would require a backend server, the data will be persistent using Firestore. So Firestore is like a data storage system on Google. If you intend to take the Google Cloud, either the machine learning engineer, or you're taking the associate cloud engineer, or you are taking any of the Azure certification, I don't mean workspace, then you understand different data storage systems. Or even if you take the entry-level Google Digital Leader, you understand all of the different file storage systems that Google have and where they can be applied. Now, here's the HTML and JavaScript code for your wallet system. So this is how it works. So it's a simple HTML JavaScript. Then it has wallet balance, transaction history, simulated approval, real-time data, persistent user authentication. This is how it works. If you purchase over 500, it's going to be rejected. Purchases with description containing luxury items are rejected. Amounts must be greater than 0. Backend or API integration. So it's not suggesting and saying, okay, we need a backend server because it needs to save this data so that it can keep that history. Because the difference between a front-end application and a backend application is that for a front-end application, we are not going to be doing storage. We're not going to be keeping data. We're not going to be making decisions based on what happened in the past. We just provide information. That's why it's called front end. You just have literal text or literal actions that is either HTML, CSS, or JavaScript driven. But if it's a backend application, that means it's a dynamic application. It's database driven. We can keep data and tell you, okay, this is what happens so and so time. So it's not suggesting that we should use Node.js with Firebase Cloud Functions, or we use Python, or if you want to go for PHP or ASP, whatever kind of backend language and a database you want to use, you could do that. Now, it's saying we can now call Vertex AI to analyze the expense, the description, the category, and even the employee's expense pattern. That's why you see AI being deployed in finance. Apply your defined admin rules. That's to say that you can have set of rules, then the AI can now complete the rest based on the algorithm that you are piggybacking on. Then you can now return to tell the client, okay, it's approved or it's not approved. So admin portal, this is what it looks like. Enhanced security. So this is an AI-driven, let me just try something and see, let's say luxury. Luxury, it contains luxury, make purchase. So it's going to process the purchase. Oh, you're doing something that has to do with luxury, or you've exceeded the 500 limits. Sorry, you're not going to have there. So this is a classical example of an AI-driven system. Now, don't forget to subscribe to the channel. I hope to bring AI-driven system. I've done some AI-driven system for students, maybe taking cybersecurity courses that intend to create script, intends to create application, maybe that can do auto tracking, that can do all of those kind of stuff. Check the playlist on web programming in the channel. You're going to see that. I'll see how to also drop a description in this video. Okay, I think that's all for module 3 in the navigating the landscape. So this is how you can understand the building blocks of AI and how you can also deploy it for your solutions.